Welcome back to Industrial Automation course. We will continue with lecture 14, part 2, Siemens S7-1200 PLC and the Siemens Totally Integrated Automation Portal. Today's topics are as follows: introducing the Siemens TIA portal, creating a project, connecting a Siemens PLC S7-1200, creating a simple program in ladder logic diagram, uploading the program to the PLC, and running and testing the program. So here we could see different portals, and we could choose which one we wish to choose. Here we see the actions for different portals. Here we could see different selections for that action. Here we could switch to the project view or portal view. And here it's basically display for the current project. Okay, so in the project view, here we have the menu bar on the top. So have project, edit, view, insert, etc. We have toolbars. So these are toolbars. Okay, so going online or stopping the PLC or running PLC and the other basically toolbars that you could basically see here. We have project tree. We have work area. We have task cards. Okay, so here is the task cards here on the right side. Here we have a details view. We have inspector view window. And here we have switching to the portal view. Okay, so you remember that we could switch between project view and the portal view, and this is what you could see in the project view. Okay, so loading a project, what we should do to load a project. Let's say we have one existing project or we want to open one sample project. This is what we could do. We could start from the portal view, okay, then open existing project. Then we need to browse and in the local memory to find our project, select the. Now we want to create a project. So instead of opening existing project, we should select create new project, give it a name, a path, a name of the order, and then create. Okay, 1, 2, 3. Then after that, we should insert and configure our PLC. So we should say the software, the TIA, what is our hardware? So we need to go to the configure a device. And then in the configure a device, we need to select our hardware. So make sure that you have a network connection between your PC and PLC. This can be done in 2 ways. So these processes that I'm explaining here is when we have a real hardware, and we used to do this in the lab when students could have access to the PLC. Of course, now you don't have access to PLC, but what you will do the configuration of the hardware, and instead of using the PLC, the real hardware device, you will use a TIA PLC sim. So you will do the simulation instead of loading to the hardware. But anyway, I will go through these slides because I want to introduce you the TIA, what do we mean by the IP address, and etc. Okay, so first, connecting both PC and PLC to the LAN network. In this case, we need to know the IP address of the PLC in order to be able to connect to it. So here we have our PC, and here we have two PLCs, and here we have two HMI panels. And what we did, we connected all of these through a switch and with the LAN network to our PC. So we need to know the IP address of the PLC or HMI panels in order to communicate with them, and in order to know exactly which program belongs to which PLC and what actions belong to which device. The second way is connecting PC directly to the PLC using the LAN cable. Okay, let's say when you have only one PLC. In case you want to connect one PLC, and it was the case in the lab, it was the simplest example, it was an introduction to PLCs, then you need to use the second option for this example, since we'll use only one PLC in this session. So through the example that I'm going to introduce to you, we only use one PLC, and later we could make it more complex by adding, let's say, one HMI panel or more PLCs to our hardware configurations and networks. Okay, so let's now continue with inserting and configuring our PLC. So what we have done so far, we created the project, okay, but inside the project we need to add our device. So you need to select the here second option, add new device, choose PLC, and then you have list of PLCs. So in the list of PLCs, go to CPU and CPU 1212, C, AC, DC, okay, and go for the second option. And for the version, choose version 3. Okay, so version also is important. This is a version of the firmware on the PLC. Okay, you could basically update or change the firmware sometimes on Siemens PLCs, but anyway, the configuration on the TIA portal should match completely with the hardware and the firmware on the PLC. Okay? And then finally, you will click on the add. Once you do so, then here you will see your PLC. Okay, it's very similar to the real hardware S7 1200. Okay, and what we need to also set the IP address. Here you could see the LAN port, and if you click on the LAN port, then you will see settings for the IP address. Topology view, so here you could see a topology view, network view, and device view. And if you click on the topology view, this is what you could see. Okay, so now click on the device view, and here you could see a Profinet interface. Click on the Profinet toolbar, Profinet port here if you don't see that. Okay, once you click on the Profinet port, you will see the Profinet interface. Then you need to choose the IP address and the subnet mask. Okay, select the IP address and subnet mask, and once you are done with this, then you could switch to another window. Okay, so you are done with setting IP address and subnet mask. Since we don't have a real device, so You could choose whatever numbers here, it doesn't matter, because we are going to use with the PLC simulation. Now you should open organization block, open the program blocks folder in the project tree. So go back to the project tree, and here you have your program blocks. Under program blocks, you will see these basically sub branches, and you have main organization block. This is what automatically created once you create the project. Okay, choose the main organization block, double click on that, and then you will see the programming environment. Okay, so these are the processes 1, 2, and 3. Okay, so once you do so, you will see this environment. Okay, so once you have clicked on this main organization block, now you could see the environment for the programming, and here we could program or PLC based on ladder logic. Okay, so again, click on this. Overview of the program editor. Here we have the main toolbox. Okay, and this one is, if you click on this one, once you are in online mode, you could see online what's happening inside the program, what is the status of each coil and contacts. Here we have variable interfaces. You could see the status of all the variables. Here we have another toolbox for selecting contacts, coils, or creating a new branch, for selecting a box and choosing timers and counters, etc. Here we have the main network. You have your rung here. You see the contacts and the timers and coils. Okay, one example. Here again, you could see some favorite instructions. Here you have a basic instructions that you could choose. Whatever you have here, you could find it here, and you could find much more. For example, timer operations or bit logic operation or counter operation. So mass functions and etc. All of that could be found here. And you have extended instructions, a little bit more advanced instructions could be also found here. Networks in the ladder logic programming language. The program of an organization block is divided into networks. The networks are used to structure programs. Each block can contain up to 999 networks. LAD instructions are contacts, coils, and boxes. So here we have all of that. We have contacts, we have coil, we have box. You could see a power rail, rung, branch, contact, coil, box, and you could see a negated contact. Create a program for switching an example machine on and off. Okay, so from now on, we start programming for project. So we created a project, we configured the hardware. Now it's time to make our hand dirty with the software and start programming. Our aim is to use one input key similar to push button in order to turn on and off two machines. Whenever one machine is turned on, the other one will be turned off, and vice versa. So let's say we could have one start switch and two motors. Once we press a start, one of them should start, the other should be off. and once we release it, it should be opposite. The one that started first should be stopped, and the other one should start. Activate the symbolic representation of the tag. So from this menu, choose the symbolic. Insert a normally open contact into the first network of the block. Okay, so here this is our normally open contact. You could just select the wrong here and press on this one, and once you do so, you will see the contact. Okay, so you see the processes, first symbolic, then here normally open contact on the wrong. Open the instructions task card. If you click on the instructions, you will see this window. Then you could have access to both basic instructions and extended instructions. Insert the output coil instruction at the end of the program wrong. Okay, so here you could choose a coil here, or from the bit logic operations, you could choose a coil here. Once you do so, you will see a coil. Okay, so now you see that none of the contacts and coils have any addresses so far. Okay, now we have one contact and a coil. Now we could create a branch. Click on this icon here, and this icon will give you the open branch. Okay, now one branch is created. Now you could insert another coil. Now insert a negated coil. Okay, now you have a negated coil. Or you could right click on a normal coil and choose negated. Okay, so this is another option of right clicking on a normal coil and changing the type of the coil. Okay, so now you are done with the program, but we need to assign some addresses and tags. So what are PLC tags? Tag is a variable used in the program that can take on different values. Could have a local tags apply only in the block that are defined, and we have PLC tags applied throughout the entire PLC. So it's like a local variables and global variables. PLC tag components could, for example, could give it a name. So let's say conveyor on. Okay, so let's say the name of one motor is conveyor on. Okay, it's the one that switch on the conveyor. Okay, so you could choose whatever name you wish. Okay, then we need to select a data type. For example, that one is a Boolean, either off and on. And we could also specify an address, let's say M3.1. So in Siemens PLCs, if the address starts with I, it means that this is a real input device, and if that starts with Q, it means that this is a real output device, and when it starts with M, this is the internal memory. Okay, or so it's not assigned to any specific real devices or field devices, just one address inside the memory. What are PLC tags? So you see that for different contacts and coils, we selected a name and one address. So variable one, and the address is I0.0. The other one is output Q0.0. Here in the tag table, you see the name, data type, and address. For this one, This one is just internal memory. It starts with M, and you see where is the address inside the bit memory address. And these are real input and output devices. Okay, so let's continue with our example and defining tags and addresses. So click on the contact and directly basically write the name you wish, on off switch in the operand placeholder of the normally open contact and confirm it. Then right click and define tag. Now in the tag table, you could choose the address, you could choose the data type, and you could choose if that is a global memory or local memory. Okay. For now, leave every addresses as a global memory. This one is, let's say, real input device. So we choose a one that starts with I, and just select I 0.0 for now. We need to do the same for coils. Give it a name, right click, and define a tag for each of them. For example, for the one that we name it on, choose Q 0.0. And for the other one, we choose a name off and choose Q 0.1. Okay, now you define your tags and addresses. What you need to do, you need to save the project. Okay, so you are done with the programming, but you need to test the program. To load the program to the PLC, follow these steps. Start the load process by selecting download to device, software, all blocks. Okay, so click on the PLC, download to device, software, all blocks. What you could do before downloading to device, you could compile it. If you don't see any errors, it means that you are fine with downloading to device. But anyway, the TIA portal will compile the program before downloading. So even if you don't compile it and choose to go directly to download to device and select software all blocks, let's say, the TIA portal will compile it first to see if the program doesn't have any error, because it doesn't want to download a program with error to the PLC. Okay, so if you do so, you will see this window, and you need to do the following selections in the dialog box to select the correct PLC. Here for the interface, select PNIE. This one, most likely you will have only Broadcom. Depends on the type of your PC or laptop. And then you will see the addresses of your devices connected to the PC. For example, if you have one PLC, you could see only one device with one address. If you have connected many PLCs and the HMI panels, you will see all of them here with their names and addresses. But in this case, we only have one. Okay, so I know that you don't have the real hardware, so you need to watch another video that I put it on Moodle. Watch that one to see how you could use PLC sim and how you could download your program to the PLC sim instead of the real hardware. Click on load in the load preview window. Okay, so this is a load preview window. And then you could select start all if you wish to start the device right after the downloading is finished. Otherwise, you could untick this one and finish downloading and start your PLC manually. Okay, so click this one for now and click on finish. Now your program is downloaded on PLC, and PLC is ready for taking actions similar to your program. So if you wish to see what's going on in your PLC, you need to go online. Okay, you want to monitor your PLC. So click on go online, and in order to observe the values of the variables online, turn on the monitoring on off in the program block window. This is basically monitoring icon that if you click on this one, you will see the status of contacts and coils if they have a true or false values. And if you do so, you will see the program here. Okay, so you are online and you are monitoring your program. When the monitoring is turned on, the instructions will be highlighted and their color will depend on their logical value. So when is blue, it means that the contact or coil is false or has a false status, and once is green, it means that has a true status. The input key, or this one, is not pressed, so its logic is false. According to the on output will be energized, will not be energized, sorry, so this one will not be energized, as you could see is false. On the other hand, the second output will be energized since it's normally closed one. This is a real device, and you see the basically outputs and inputs here. The first LED is the tag one, or we call it switch on and off inside or program. Once the first LED is off, it means that this switch is off. The second output is on, it means that the second output is on, and the first one is off, it means that the first one is off. Okay, so you have this nice hardware interface here. You could see what is the status, plus you could see a run and stop here, but you see that the PLC is running the program now. So it's basically going through the cycle of scanning the inputs and updating outputs. So here you could continue testing the program, and you could switch the input on. Or if you are using PLC sim, you could right click and force the value to 1. Again, watch that video how you could use the PLC sim instead of a real hardware. And now you could see the color code has changed. The first one is green and the second one is blue. Now you should do the exercise. Go offline and stop the program. You need to modify the program in the following manner. You need to use 2 input keys. By pressing the first key, you need to have the output coil energized. Afterwards, if you turn off that input key, the output coil should still stay energized. In order to de-energize the output coil, you need to use the second input key. So it's basically one start and stop button. Once you press the start, even momentarily, the output should go on and stay on. And if you want to turn off that device, you need to press stop. Therefore, you need to define 3 tags and assign them to PLC input and outputs. After showing your design, upload the program to the PLC and test it in real time. You could easily do that with PLC sim, and I expect students to exercise this program.